Alright, we're going to do some examples on properties of logarithms. So, in example 1, we have log base 3 of 4x. So, 4x can also be said as 4 times x. So, when it's 4 times x, that means it's the multiplication or the product. So, in this example, we're going to use the product property. So, when we have this, we can rewrite it, and I'm going to write equal sign. So this will equal to log base 3 of 4, because that's the one that came first, plus log base 3 of x. And then that's it. Now, in example 2, we have log base of 6 of 7m, or 7 times m. So 7 times m, that means it's the multiplication or the product property. So again, we're just going to rewrite it using the product property. So log base of 6 of 7m can be rewritten as log base 6 of 7, and again, I wrote 7 because that came first, plus log base of 6 of m. And then that's all you can do. So again, I just rewrote log base 6 of 7m as log base 6 of 7 plus log base 6 of m using the product property. So example 3, we have log base 7 of 3 plus log base 7 of p, the letter p. So we see that there's an addition between these two logs and they have the same base. Log base 7 here, log base 7 over here. So the only thing that has additions with the property is the product property. So in this example, we're going to combine as one log. So again, we're only using the product property, so we're going to combine these two logs as one. So I'm going to write log base 7, and then since this one's first, I'm going to write 3 first, and then here is p, so I'm going to write p second, and then that's all we can do. So again, I just combine these two logs as one log, so log base 7 of 3p. Now over here, example 4, we have log base 5 of x plus log base 5 of 9. That's pretty much the same as example 3, so it has a plus, so we're going to use the product property. We're going to combine these two logs as one. So they're both log base of 5, so I'm going to write log base of 5. Now, what came first is x, so I'm going to write x times, and then 9 is second. So when we have something like that, we can't just leave it like that. So just like how we did before in Algebra 1, Geometry, and Algebra 2, if it's x times 9, we usually have the number in front. So we can rewrite it as log base 5 of 9x. And the reason we can do that is because it's multiplying. It's the same thing as if I were to ask you, what's 3 times 4? And it would be 12. Well, what's 4 times 3? Also 12. So here we can switch the number because it was multiplying. So it's the same thing up here. So x times 9 is the same thing as 9 times x, or 9x. So again, this is the answer when we combine these two logs together. Alright, in these examples we have division or quotient. So in example 5 we have log base 8 of 5 over x, or 5 divided by x. So again, division, fractions, quotient. That means we're going to use the quotient property. So what we're going to do is just rewrite this. So log base 8 of 5 over x is simply equal to log base 8 of, since 5 is on the top, 5 will go first, minus log base 8 of x. So that's all we have to do in that example. Now, our sixth example, or example 6, we have log base 4 of f divided by 7. So again, division, so we have to use quotient property. So that's simply going to equal to log of 4 of f, and the reason is I started with f because f is on top, minus log base 4 of 7. And again, that's all I can do. So I just rewrote log base 4 f divided by 7 as this. Log base 4 of f minus log base 4 of 7 using the quotient property. Alright, let's take a look at example 7. In example 7, we have log base 2 of 9 minus log base 2 of m. So if we were going to rewrite it using the properties of logarithms, we see that there's a minus, so the only property that has or involved with minus is the quotient property. So all I have to do is going to rewrite this as a single log. So both of them has log base 2, so we can do that. So log base 2, and then we're going to write it as a fraction. So what comes first from the left is 9, so I'm going to write 9 on the top over what comes second, which is m. So I'm going to rewrite it like this. And that's all we can do. Now over here, what's different from the previous examples is that we have natural log, ln. So in example 8, it's going to be the same property because it has the minus. And all we're doing is just going to follow the same step as before. So natural log, so we can just write simply natural log. And then what comes first from the left is k, so k will be on top. And then what comes second will be on the bottom, which is 6. So this is natural log of k divided by 6, or k over 6. And again, in the previous example we all use log, and in example 8 we use natural log. That's okay. It still follows the same properties. So these two are the quotient property. Alright, here we have 3 examples and they all have exponents, so that means we're going to use the power property. So in example 9, we have log base 7 of 4 to the third. Now, if we just simply rewrite it in a different form, so we can just rewrite it as 3 times log of 7, or base 7 of 4. So that's all we can do. So 3 log base 7 of 4. And then again, the reverse order can be the same. If we start with log base 7 of 4, you can rewrite it as log base 7 of 4 to the third power. And then there's something that I didn't mention. So here, log base 7 of 4 to the third can be rewritten as log base 7 of 4 to the third power. Notice how I switch the parentheses. So now the parenthesis over here is only on the 4. Over here, the parenthesis covers 4 to the third power. So you can rewrite it and it's still the same, regardless. But you can only do this when it has an exponent. So that's the only time you can rewrite with different parentheses over the 4 or over 4 into the third power. Now example 10, we have log base 5 of x to the 9 power. So we can rewrite it as 9 log base 5 of x. And again, we make a darker 9. You can go in different order. So if you start off with 9 log base 5 of x and you want to rewrite it, then it be rewritten as log base 5 of x to the 9 power. Or if you start off with log base 5 x to the 9 power and then you're going to rewrite it using the power property, it would be 9 times log base 5 of x. Now, example 11, we only have just variables and is using a natural log. And again, natural log follow the same properties as log. So, if we were just to rewrite it, it would be m times natural log of x. So, that would be the written form for this log of x to the m power, written as m times natural log of x. Or if you start off with m times natural log of x, you can rewrite it as natural log of x to the m power. So, in summation, all we're doing is just writing in a different form, and then you get used to this. Once you get used to this, you can start solving for variables or isolating to solve or evaluate logarithms. So that's the purpose of properties of logs, especially when we're going to be using them to solve for log equation and exponential equations.